So today we're going to talk about naming acids. And in order to have an acid, it needs to start with an H+. And you do use hands in order to write the formula for an acid. That's really important because acids are technically molecular compounds. If they have an H+ in them, that's not a metal. So they will be a molecular compound, but you don't use the prefixes. So that's the weird, different thing about acids. There are two types of acids. One type has no O, and one type has an O. O being oxygen. I'll give you a couple examples of each, and then we'll name them. So, for example, a no O would be HCl. It starts with an H. It has a Cl in it. So here I have an acid because of that H, but there's no O. Versus an example over here with an O. It still has to start with an H, but maybe it's HClO3. Another example over here, something like HF. Again, starts with an H, no O. Another example over here would be something like HClO by itself. Also has an O. Now I'm going to show you a procedure for naming each of these. So if I look at HCl, the procedure for naming a no-O acid is hydro. You fill in the element name, blank-ic acid. For example, this would be hydrochloric acid. The blank being the chlor because this is chlorine. So you take the stem of that word chlor and turn it into hydrochloric acid. This, same thing. Hydrofluoric acid. So a third example would be if I gave you something like hydrosulfuric acid and asked you what was the formula. Well, I look and I see hydro. Well, hydro tells me there's no O, so it basically has hydrogen, and I don't know it has hydrogen because it starts with hydro. I know it has hydrogen because it says it's an acid, and hydrogen has one hand, so I'm going to start by drawing that. Then I look and it says sulfuric. Well, sulfur is one of those weird things where it should technically say hydrosulfic acid, but that sounds funny, so we do change the name to hydrosulfuric, and I know that comes from sulfur. If I check on my periodic table, sulfur has two hands, so I all of a sudden realize I need another H+. So my formula for hydrosulfuric acid is actually H2S. Now I'm going to go on to the kind with the oxygen. There are actually two rules for this, and I will write them down here. So the rules for with oxygen are an 8 goes to blank-ic acid, and an ite goes to blank-us, O-U-S, acid. So anything that has an O in it with another element is going to be on your polyatomic ion cheat sheet. All of those things end in ate or ite. So I look at the polyatomic ion that's within my acid. ClO3 has a -1 charge. Well, that's why there's just one H, because if this has a -1 and H has a +1, they both have one hand. This is called chlorate. Notice how that ends in ATE. That means it's going to be this type. So it's going to be chloric acid. The 8 turns into the ic. So this is chloric acid. This, however, I look at it and I look at ClO. So it has no, it must be on my cheat sheet. Well, that is going to be hypochlorite. Sorry if I go off the screen. It is hypochlorite. Looking at that, it ends in ITE. The hypo just distinguishes it from chlorite, which would be ClO2 minus. So this would be called chlorous, O-U-S, acid, because it ends in ite. So I changed the ite to an, oh sorry, made a mistake. It would be hypo, I can't just get rid of that, hypochlorous acid, because I keep the entire polyatomic ion word except for the ITE or AT ending and change it. The only last example that I want to show you continues on if you do have an O, and it would be, what is the formula for sulfuric acid? Well, I look at that and you notice all of a sudden I have no hydro, so it must come from a polyatomic ion. It ends in an ic, so it must come from sulfurate, which doesn't make sense. But remember, I told you about sulfur being weird. So this must come from sulfate. Sulfate is SO4 2 minus, so it has two hands. Therefore, I know when I turn it into an acid and add hydrogen, I must have two hydrogens. So the formula for sulfuric acid, SO4 with two H's. So H2SO4.